Hello friends, I am Assi welcoming you in the solution session of assignment 3.3. In this assignment, you are going to see how can we find inverse of 3x3 matrix, and in second part we are going to solve some example using principle of mathematical induction. So let's go for the questions. In this question, we have to find inverse of the given matrix. We know that the first step is write in the form of A is equal to IA, and then let's start to get identity matrix on the left side. And for that, the first step is to get leading one at A11 point, right? And for that, I think we should subtract the third row from the first row. And for that, we need to operate R1 gives R1 minus 1 R3. That means we have to multiply the third row to minus 1 and then add into the first row. Then 2 into minus 1 gives us minus 2, 0 into minus 1, minus 0, 1 minus 1 will be minus 1. Same thing on the right side. It will give us 0 into minus 1, minus 0, 0 and minus 1. As you can see, in this process, our second and third row will be as it is. First row will be changed to the 1, minus 2, minus 2, 1, 0, minus 1. We complete our first step. Now we should move to the second step, in which we need to get 0 at A21 and A31, and for that recommended process is R2 gives R2 minus K, or we can say minus 4. This will become plus 4 R1, and to get 0 at 31, we will do the second process. Okay, so first of all, let's get the 0 at A21 by multiplying first row to the plus 4 and then add to the second row. So it will give us 1 into plus 4, minus 2, 4 is minus 8, plus 8, minus 8, and same thing on the left side will give us plus 4, plus 0 and minus 4. In this operation, our first row will be as it is. Second row will be 0, minus 7, minus 9, 4, 1 and minus 4. Right? Now it's time to get 0 at A31 point in this same step, so we can reduce the steps. Okay, and that can be achieved by the operation R3 gives R3 minus L, or we can say 2 R1, right? That means we will multiply our first row to the minus 2 and then add to the third row. So 1 into minus 2, minus 2, minus 2, minus 2 is a plus 4, minus 2, minus 2 is a plus 4 again. Same thing on the right side, and it will give us minus 2, plus 0 and plus 2, which transform our third row into 0, 4, 5, minus 2, 0, 3. Okay, so here we complete our second step. Now we should move to the third step, in which we need to get leading one at A22 point without using first row. We can't use the first row in this process. Okay, so it is preferable to multiply to the third row and then add into the second row. So we'll get leading one at A22, right? So to get leading one, we should take operation R2 gives R2 into K, or we can say 2 R3. So let's multiply third row the 2 and add to the second row to get leading one. It will give us 0, 4 2s are 8, 5 2s are 10. Same thing on the right side, will give us -4 plus 0 and plus 6. As you know, in this process our first and third row will be as it is, so here they are, and our second row is transformed into 0, 1, 1, 0, 1 and 2. Here we complete the third step. We get leading one as well as value of n and m, right? Now let's move to the next step, in which we need to get 0 at A12 and A32 point. By taking the operations, R1 gives R1 minus n, or we can say -2, so it will be +2 R2, and R3 gives R3 minus m, or we can say 4 R2, right? So in both process our second row will be as it is, so let's write down as it is. Now our first row is transformed by R1 plus 2 R2. That means we have to multiply second row to the 2 and then it will add to the first row, so we'll get 0 2s are 0, 1 2s are 2 plus 2. Same thing on the right side, will give us 0, 2 and 4, which will give us 1 0 0, 1 2 3. Now let's get the third row, which is transformed by R3 minus 4 R2. That means we have to multiply second row to the -4 and then add to the third row. 0 into -4, 0, -4, 1 -4s are -4. Same thing on the right side, will give us 0 into -4, 0, 1 into -4, -4, 2 into -4, -8, which will give us 0, 0, 1, -2, -4 and -5. So we complete the step. Next step is get the leading one at A33 point. But Bhagwan ni daya hai, we already have the leading one, so we also complete this step. Now we move to the last step, in which we need to get 0 at A12 and A32. Bhagwan ni to double daya hai, we already have 0 at A12. We just need to get 0 at A32, and for that we just have to take the operation R2 gives R2 minus Q, or we can say 1 R3. Okay, that means we have to multiply third row with -1 and then add to the second row, so we will get 0 0 and -1. Same thing on the right side, will give us +2, +4 and +5. And we know that in this process first and third row will be as it is, so let's write down as it is, and our second row will be 0 1 0 2 5 7. So yes, we get I is equal to A inverse A form, which suggests that our A inverse is 1, 2, 3, 2, 5, 7, minus 2, minus 4, minus 5. Now let's see the option. Option C is your answer. Ta-da! Here we have one little cute question. You have to find inverse of this matrix. Actually, the matrix is identity matrix of order 3 cross 3, and the inverse of identity matrix is itself. So the option B is the answer. Ta-da! In our next question, we have to find inverse of this matrix. Actually, both 1 and 0 છે એટલે અઘરું નહીં પડે, but we should follow the tradition. First step is write in the form of A is equal to IA. Here it is. Now the first step is to get leading one at A11 point. We have one, but it is not at A11 point, right? So the preferable option is, let's interchange first and second row. So our first row will be 1 0 0 0 1 0, and the second row will be 0 1 0 1 0 0, and third row will be as it is. And oh my god, we already get identity matrix on the left side. That means we get our A inverse on the right side. So our A inverse is actually 0 1 0 1 0 0 0 0 1, which is exactly same as A. So our answer inverse of A will be A itself. Ta-da! And one more thing, you should note that A is not the identity matrix. Still, A inverse is A, right? Here we have one interesting question. You have to find inverse of the given matrix. Actually, this is a upper triangular matrix, right? So, and it is very close to the identity matrix. So hopefully question will be quite simple, but you have to follow the tradition. First of all, you have to write in the form of A is equal to IA form. Then get the leading one at A11 point. Bhagwanni dayathi, we already have A1 at A11 as well as 0 at A21 and A31. So first and second step is completed. Now the third step is get leading one at A22. Oh my god, we already have the leading one at A22 as well as 0 at A32. Now we just need to get 0 at A12, and for that we already have the value of n is equal to 2. So let's do the operation. R1 gives R1 minus n, or we can say 2R2. Okay, and in this operation our second and third row will be as it is. So first of all, let's write down as it is. First row will be get by multiplying minus 2 to the second row, and then let's add into the first one. So we'll get 0, then minus 2 and minus 4. Same thing on the right side will give us 0, minus 2 and plus 0. Originally we have 0 over here, right? Okay, so our modified first row will be 1 0 minus 1 1 minus 2 0. So we complete our fourth step also. Now we need to get the next step, in which we need to get leading one at A33, and we already have the leading one at A33. So we get the values of P, R and Q, right? So we can easily get the 0 at A12 and A32 by the process R1 gives R1 minus R, or we can say minus 1 will become plus 1, R3, and R2 gives R2 minus Q, or we can say 2, R3, right? And in both operation our third row is as it is, so let's write down third row as it is. Now let's get the first row by multiplying third row with the plus 1 and then add to the first row. So 0 ones are 0, 0 again ones are 0, 1 ones are 1. Same thing on the right side, give us 0, 0 and plus 1, which will give us 1, 0, 0, 1 minus 2, 1. Now it's time for the second process, in which we will multiply third row to the minus 2 and then add to the second row. So 0 minus 2s are 0, 0 and 1 minus 2s are minus 2. Same thing on the right side will give us 0 minus 2s are 0, 0 and minus 2, which will give us 0, 0, 1, 1, 0 and 0, 1 minus 2. So we get I is equal to A inverse A form, which suggests that our A inverse is 1 minus 2 1, 0 1 minus 2 and 0 0 1. Ta-da! Option B is your answer. Here you should know that the inverse of upper triangular matrix is also upper triangular matrix, right? Remember this, it will helpful in future. Question, we have to find inverse of the given matrix, and first of all we have to write the form of A is equal to IA, and then our first step is to get leading one at A11 point. Actually in first column we have the leading one but not at the A1, right? So to get this one on the first row we have to exchange first and second row, and in this process our third row will be as it is. So let's write down as it is. Now second row will become your first row, so 1 2 3 0 1 0, and the first row will become your second row. So finally we get the leading one as well as we get the 0 at this point. So we just need the value of L, right? Okay, now let's move to the next step. We already have the 0, now we just need 0 at A31 point. For that we need to take the operation R3 gives R3 minus L, or we can say 3R1. So in this process our first and second row will be as it is, here as it is. Now the operation, we have to multiply first row to the minus 3 and then add to the third row. So we'll get 1 into minus 3 minus 3, 2 into minus 3 minus 6 minus 9. Same thing on the right side will give us minus 3, 0 minus 3 is 0, 1 minus 3 minus 3, 0 minus 3, 0. So third row become 0 minus 5 minus 8, 0 minus 3, 1. So we complete this step and we already have the leading one at A22 point. That means we get AND as well as m, right? Now we should move to the next step, in which we need to get 0 at a12 and a32 by the operations. R1 gives R1 minus n, or we can say 2R2, and the second operation will be R3 gives R3 minus m, or we can say plus 5 R2. So in both process, our second row will be as it is. So just write down second row as it is. Now let's get the first row by the operation R1 gives R1 minus 2R2, in which we have to multiply second row to the minus 2 and then add to the first row. 0 minus 2 are 0, 1 minus 2 are minus 2, 2 minus 2 are minus 4. Same thing on the right side will give us minus 2, minus 0, minus 0. Will give us 1, 0, minus 1, minus 2, 1, 0. And the next operation is second row multiply with 5 and then add to the third row to get 1 at a32. So 0 5s are 0, 1 5s are plus 5, 2 5s are plus 10. Same thing on the right side will give us plus 5, plus 0, plus 0. So the third row will be 0, 0, 2, 5, minus 3 and 1. So here we complete the step, we get leading 1 and zeros. Now in next step we need to get 1 at a33 point by taking 2 common from the third row. So we should take the operation R3 gives 1 by 2 R3. This process, our first and second row will be as it is. So let's write down as it is. The third row will be 0 by 2, 0 by 2, 2 and 1. Here we'll get 5 by 2, minus 3 by 2 and 1 by 2. So finally we get leading 1 at a33 as well as R and Q, which will helpful to get 0 at a13 and a23. In the operation of R1 gives R1 minus R, or we can say minus 1. So it will become plus 1 R3, and the next operation should be R2 gives R2 minus Q, or we can say 2 R3, right? In both process, our third row will be as it is. So let's write down as it is. Get first row, we have to multiply third row with the plus 1 and then add to the first row, will give us plus 0, plus 0, plus 1. The same thing on the right side will give us plus 5 by 2, minus 3 by 2 and plus 1 by 2. Will give us 1, 0, minus 1, 1 by 2, minus 1 by 2 and 1 by 2. Now the next process, in which we have to multiply third row to the minus 2 and add into the second row. So here we'll get plus 0, 0 and minus 2. Same thing on the right side will give us minus 5, plus 3, minus 2, minus 1. So our second row will be 0, 1, 0, minus 4, 3, minus 1. So yippee, we get I is equal to A inverse A form, which suggests that our A inverse is 1 by 2, minus 1 by 2, 1 by 2, minus 4, 3, minus 1, 5 by 2, minus 3 by 2 and 1 by 2. So let's see the option. Option A is your answer. Ta-da! In our next question, we have to find inverse of this matrix, and we know the first step. Just write down in the form of A is equal to IA. And then we will try to get reduced row echelon form on left side. For that, we know the steps. Our first step is to get leading one at A11. We already have leading one at A11. So, and we get the value of K as well as L, which will help in the second step to get 0 at A21 and A31 point. Using the operations, R2 gives R2 minus K, or we can say phi R1. So let's do this operation. We have to multiply minus 5 to the first row. So multiply minus 5 to the first row and add it to the second one. So here we will get minus 5, minus 10 and minus 25. Same thing on the right side will give us minus 5 plus 0 and plus 0. Okay, now it's time for the second operation, in which we have to take R3 gives R3 minus L, or we can say 3R1. That can be done by multiply minus 3 to the first row and add it to the third row. So it will be minus 3, minus 6, minus 15. Same thing on the right side will give us minus 3, 0 and 0. So in this process, our first row will be as it is, and second row will be 0, minus 9, minus 24, minus 5, 1 and 0, and third row will be 0, minus 6, minus 11, minus 3, 0 and 1. Okay, so we complete our second step. Now it's time to get leading one at A22 point, and that can be done without using first row. Here preferable option is taking minus 9 common from the second row. I mean to say, we have to take R2 gives 1 by 9 R2. So first and third row will be as it is. So let's write down as it is. And our second row will be 0, 1, 8 by 3, minus 5 by 9, actually plus 5 by 9, minus 1 by 9 and 0. So we get the leading one as well as the value of N and M, which will helpful the next step to get 0 at A12 and A32. Okay, so the first process will be R1 gives R1 minus N, or we can say 2R2. So we have to multiply minus 2 to the second row and then add to the first row. So it will give us plus 0, minus 2, 8 by 3 into minus 2 will give us minus 16 by 3. Same thing on the right side will give us minus 10 by 9, plus 2 by 9 and 0. Okay, now it's time for the second process, in which we have to do R3 gives R3 minus M, which is your minus 6, so it will be plus 6 R2. That means second row will multiply with 6 and add into the third row. That will give us plus 0, plus 6 and plus 16. Same thing on the right side will give us plus 10 by 3, minus 2 by 3 and plus 0, right? So in this process, our second row will be as it is. Here it is as it is, and first row will be 1, 0, 5 minus 16 by 3 will give us minus 1 by 3, then minus 1 by 9, 2 by 9 and 0, and third row will be 0, 0, 5, then 1 by 3, minus 2 by 3 and 1. So we complete this step. Now it's time to get leading one at A33 without using first and second row. So compulsory we have to take 5 common from the third row. That means we have to take operation R3 gives 1 by 5 R3. In this process our first and second row will be as it is. So here they are as it is, and the third row will be after taking 5 common 0 0 1. Here we'll get 1 by 15 minus 2 by 15 and 1 by 15. Okay, now we reach to the last step, and as well as we get the value of R and Q. Okay, so the first operation of the last step is R1 gives R1 minus R, which is actually minus 1 by 3. So it will become plus 1 by 3 R3. That means third row will multiply with minus 1 by 3 and add into the first row. So it will be plus 0 and plus 1 by 3. Same thing on the right hand side will give us plus 1 by 45 minus 2 by 45 plus 1 by 3. Here we have 1 by 5, right? So here we will get 1 by 15. Okay, now it's time for the second operation, which is R2 gives R2 minus Q, which is 8 by 3 R3, right? So here we have to multiply third row to 8 by 3 and add to the second row. So it will give us plus 0 minus 8 by 3. Same thing on the right side will give us minus 8 by 45 and plus 16 by 45 and minus 8 by 15. Thank God we completed this step. Now in this process our third row will be as it is. So let's write down as it is. Now our first row will be 1 0 0 without any doubt, minus 4 by 45, 8 by 45 and 1 by 15. Second row will be 0 1 0 again without any doubt, and 17 by 45, 11 by 45 and minus 8 by 15. So tada, we get I is equal to A inverse A form, which suggests that our A inverse is minus 4 by 45, 8 by 45, 1 by 15, 17 by 45, 11 by 45, minus 8 by 45, sorry, minus 8 by 15, 1 by 15, minus 2 by 15 and 1 by 5. Tada! In our next question, we have to find inverse of this matrix, and you know the process. Just write down in the form of A is equal to IA. Try to get reduced row echelon form on the left side using these steps. Our first step is to get leading one at A11, which is already given, as well as we get the value of K and L. Now it's time to go for second step, in which we have to take operation R2 gives R2 minus K, which is 3 R1, right? That means we have to multiply minus 3 with first row and add into the second row. So here we'll get minus 3 plus 0 plus 6. Same thing on the right side will give us minus 3 plus 0 plus 0. Now the second operation, which is R3 gives R3 minus L, which is minus 2, so it will be plus 2 R1. So here first row will multiply with 2 and add into the third row will give us plus 2 plus 0 minus 4. Same thing on the right side will give us plus 2 plus 0 and plus 0. So our first row will be as it is, and second row will be 0 minus 1 6 minus 3 1 0, and third row will be 0, 1, minus 3, 2, 0, 1, right? So here we complete the second step. Now we need to get leading one at A22 point, and that can be achieved by multiplying minus 1 to the second row. So our operation must be R2 gives minus 1 R2, right? And our first and third row will be as it is in this process. So here they are as it is, and second row will be 0, 1, minus 6, minus 3, 1, plus 3, minus 1 and 0, right? So we get leading one at A22 point as well as the value of N and M, which will helpful in the next operation to get 0 at A12 and A32. So our first operation must be R1 gives R1 minus N, but N is already 0, so we don't need this operation, right? Okay, we just get 0 at A32 point. Using operation, R3 gives R3 minus M, which is 1 R2, right? So let's multiply second row to the minus 1 and add to the third row. So it will give us 0, minus 1, plus 6. Same thing on the right side will give us minus 3, plus 1 and plus 0. And in this operation our first and second row will be as it is, and the third row will be 0, 0 and 3. On right hand side we will get minus 1, 1 and 1, right? So we get leading one as well as 0. Now it's time to get leading one at A33 point without using first and second row. So the only option is remaining is R3 gives 1 by 3 R3. That means we have to take 3 common from the third row. So it's but obvious that our first and second row will be as it is. So let's write down as it is. And our third row will be 0, 0, 1, minus 1 by 3, 1 by 3 and 1 by 3. So we get leading one as well as value of R and Q. Now it's time for the last step. So first process of the last step is R1 gives R1 minus R, which is plus 2 R3, right? So here to multiply third row to the 2 and add into the first, so will give us 0, 0 and plus 2. Same thing on the right side will give us minus 2 by 3, plus 2 by 3 and plus 2 by 3. Now it's time for the second operation, which is R2 gives R2 minus Q, which is plus minus 6, so it will become plus 6 R3, right? Third row will multiply with 6 and add into the second one, so plus 0, plus 0, plus 6. Same thing on the right side will give us minus 2, then plus 2 and plus 2. So here you can see our third row will be as it is. So let's write down as it is, and our first row will be 1, 0, 0, then 1 by 3, 2 by 3 and 2 by 3, and second row will be 0, 1, 0, 1, 1 and 2. So here we get our I is equal to A inverse A form, which suggests that our A inverse is 1 by 3, 1 by 3, 1, 2 by 3, 1, 1, 2, minus 1 by 3, 1 by 3, 1 by 3. This is our final answer. Ta-da! Question is, if A is equal to 1, 1, 0, 1, prove that A raised to N is equal to 1 and 0, 1 for all positive integer. Okay, first of all, A is equal to 1, 1, 0, 1 is your given data. And we have to prove that A raised to N is equal to 1 and 0, 1. We are going to use principle of mathematical induction. Okay, so first of all, let me get the predefined format. Here it is. We have to prove that a raised to n is equal to matrix 1 and 0. Okay, now let's do the first step, the basis step, p of 1, in which we have to put n is equal to 1 in left hand side and right hand side. In left hand side we have a raised to n, so here we'll get a raised to 1, and we already know that a raised to 1 is the matrix 1 1 0 1, right? Okay, now let's put in the right hand side 1, the value of n is 1, and 0 1. So as you can see, our left hand side is equal to right hand side, therefore p of 1 is true. Okay, now let's go for the induction step, in which we have to assume that p of k, that means we are going to put n is equal to k. So p of n become a raised to k is equal to matrix 1k 0 1. Let's call it equation number 1 is true, and using p of k we have to prove that p of k plus 1, in which we have to put n is equal to k plus 1, then it will become a raised to k plus 1 is equal to 1 k plus 1 0 1. We have to prove this thing, so let's do it without wasting time. Our left hand side is a raised to k plus 1. We can split this in a raised to k into a raised to 1. Now after splitting, it's time to place the value of a raised to k and a raised to 1. A raised to k is 1k 0 1 from the equation number 1, and a raised to 1, it is already given that it is 1 1 0 1, right? Now we just have to simplify. Let's do the matrix multiplication to get our answer. Here we have 2 cross 2, 2 cross 2 matrix, so our resultant matrix will also have the order of 2 cross 2, 2 row and 2 column. First element, which is in first row first column, will be obtained from selecting first row and first column and multiplying corresponding term. So here we will get 1 into 1 give us 1, and k into 0 will give us 0. Similarly, second element will be 1 plus k. Now it's time for the second row's first element, which is in second row first column. So let's multiply 1, 0 with 1 will give us 0, and 1 with 0, again we get 0. Similarly, the last element will be 0 plus 1. So here we get the resultant matrix as a 1, 1 plus k, 0 and 1. So tada! This is your right hand side. So here we can say p of k is true. Okay, so p of 1 we already make it true. P of k is true, therefore p of k plus 1 is also true. Therefore p of n is true for all n belongs to capital N by PMI. So p of n, which is a raised to n 1 and 0 1, is true, hence proved. Tada! Next question is, if a is equal to ab 0 1, then we have to prove that a raised to n, which is a raised to n, b a raised to n minus 1, a minus 1, 0 1 for every positive integer. Actually, here it is given that a is ab 0 1 matrix, right? And we are going to prove a raised to n is equal to this matrix using PMI. So let me get the predefined format, and here it is. Here to prove a raised to n is this ganda matrix. Start to prove it without wasting time. Our first step, the basis step, we have to prove p of 1. That means we have to place n is equal to 1. So in left hand side we are going to get a raised to 1, and we already know matrix A is nothing but AB 0 1, right? Okay, now it's time to put n equal to 1 in right hand side. In right hand side we have about one big Ganda matrix a raised to 1 b into a raised to 1 minus 1 upon a minus 1, and in second row we'll have 0 and 1. As you can see, a minus 1 can cancel out, and here we get ab 0 1. So our right hand side is equal to left hand side, therefore our p of 1 is true. Okay, now let's go to the second step, induction step, in which we have to assume p of k, which can be obtained by putting n is equal to k, a raised to k is equal to small a raised to k, b a raised to k minus 1 upon a minus 1, 0 1 is true. Let's call it equation number 1, and using this equation we have to prove that p of k plus 1, which is obtained by putting n is equal to k plus 1, it will be a raised to k plus 1 is equal to the matrix a raised to k plus 1 b a raised to k plus 1 minus 1 upon a minus 1, 0 1. Okay, no problem. Let's start to prove it. Let's begin from the left hand side. In left hand side we have a raised to k plus 1, or we can split it into a raised to k into a raised to 1. Now we already have the value of a raised to k from the first equation, which is this big matrix, and a is already given that AB 0 1, right? Now we just have to multiply the matrix, simplify it, or get our right hand side. Okay, let's begin. Our resultant matrix will be order of 2 cross 2. So first element, which is in first row, first column, will be obtained by a raised to k into a will give us a raised to k plus 1, and this whole term is 0 will give us 0. The next term will be a raised to kb plus b a raised to k minus 1 upon a minus 1. Now the second row, first element will be 0 into a will give us 0 plus 1 into 0 will give us another 0, and the last term will be 0 plus 1. Okay, now it's time for simplification. Our first term will be a raised to k plus 1. In second term you can take b common and take the LCM of a minus 1. So a raised to k into a will give us a raised to k plus 1. A raised to k minus 1 will give us a raised to k. Then a raised to k minus 1 as it is, and our denominator will be a minus 1. Third term will be 0. And the fourth term will be 1. Right? So we can proudly say that over these three terms will be as it is, and we just have to simplify the second term, and that can be easily done by cancelling a raised to k and a raised to k. So it will be b a raised to k plus 1 minus 1 upon a minus 1, which is your required term. So tada, this is your RHS. We can proudly say that we complete all the tasks of the PMI. Therefore P of n, which is a raised to n equal to this Gandu matrix, is true for all n belongs to n. Hence proved. Tada! In our next question, given matrix A is 1 1 1 0 1 1 0 0 1. Then using PMI, you have to prove that a raised to n is equal to 1 n n into n plus 1 by 2, 0, 1, n, and 0, 0, 1. Here we have to use PMI. So let's get the predefined terms. And our P of n is a raised to n is this matrix. Okay, without wasting time, let's go for P of 1, in which we have to put n is equal to 1. So our right hand side will be a raised to 1, which is the matrix which is given 1, 1, 1, 0, 1, 1, and 0, 0, 1, right? Okay, now let's put n equal to 1 in right hand side. So here 1 instead of n, we have to put 1, then 1 in the bracket 1 plus 1 by 2, 0, 1, and 1, 0, 0, 1, right? Okay, so here we will get exactly same as left hand side matrix. So therefore P of 1 is true. Okay, now let's move to the induction step, in which we have to assume P of k is true. Okay, so let's obtain P of a k by putting n equal to k. So our left hand side will be a raised to k and right hand side will be this matrix. Okay, we have to use P of k to prove that P of k plus 1, that can be obtained by putting n is equal to k plus 1. So here we will get a raised to k plus 1 is equal to 1 k plus 1, k plus 1, and k plus 1 plus 1 by 2. We can simplify this term as k plus 2, right? Okay, second row will be 0, 1, k plus 1, and third row will be 0, 0, 1. Okay, we have to prove this tough thing. So let's begin without wasting time. In our left hand side we have a raised to k plus 1, or we can say a raised to k into a raised to 1. Now we already have a raised to k, so just put the value, and now it's time for a raised to 1, which is given in the question 1, 1, 1, 0, 1, 1, 0, 0, 1. Now we just need to get resultant matrix from the matrix multiplication. Our resultant matrix will have 3 cross 3 order. So let's begin with the first element, which is in first row, first column. So 1 will multiply with 1, will give us 1. Then k will multiply with 0, will give us 0. And final term will multiply with 0, will also give us 0. Similarly, second term will be 1 plus k plus 0, and the last term of the first row will be 1 plus k into k plus 1 by 2. Now let's move to the second row's first term, which can be obtained from multiplying second row and first column. So 0 into 1 will give us 0, plus 1 into 0 will give us again 0, plus k into 0 will give us 0. Similarly, next two terms will be 0 plus 1 plus 0 and 0 plus 1 plus k, and the last column will be 0, 0, again 0, 0, 0, and 0, 0, 1, right? Now let's simplify. We will get 1, 1 plus k, and in third term we have to take k plus 1 common, so rest of the term will be 1 plus k by 2, right? And here we will get 0, 1, k plus 1 again, and 0, 0, 1, right? Okay, now we just need to simplify this term. Rest of the terms will be as it is, so let's write down as it is. And here we just have to take 2 as LCM, so 2 plus k by 2, and tada! This is your required RHS. So we can proudly say we satisfied all the condition of PMI. So P of 1, which is a raised to n is equal to 1 and n into n plus 1 by 2, 0, 1 and 0, 0, 1 is true for all n belongs to n. Ta-da! Hence proved. Let's see the next question. If A is equal to matrix A0, 0, 0B0, 0, 0, C, then we have to prove that A raised to n is A raised to n 0, 0, 0B raised to n 0, 0, 0, C raised to n. Actually, both are diagonal matrix, right? And A is a given term and we have to prove that A raised to n is this matrix. Let's use PMI, and for that let me get the predefined format first. So here it is, where P of n is A raised to n is equal to diagonal matrix A raised to n, B raised to n and C raised to n. Okay, now let's do the first step. Check P of 1, in which we have to put n is equal to 1. Left hand side will be A raised to n, or we can say A raised to 1. And we already know the value of A. It is A0, 0, 0B0 and 0, 0, C, right? Okay. Now it's time for right hand side. In right hand side we have matrix in which we have A raised to n, or we can say 1. Rest of the terms will be 0. Then B raised to n, or we can say 1. And in last row we have C raised to n, or we can say C raised to 1. So here our left hand side is equal to right hand side, therefore P of 1 is true. The next step is the induction step, in which we have to assume P of k is true. P of k can be obtained by putting n is equal to k. So our P of k will be A raised to k is equal to small a raised to k 0, 0, 0 b raised to k 0 and 0, 0 c raised to k. Let's call it equation number 1. Using this we have to prove P of k plus 1, which can be obtained by putting n is equal to k plus 1. So here we will get A raised to k plus 1 is equal to small a raised to k plus 1 0, 0, 0 b raised to k plus 1 0, 0, 0 c raised to k plus 1. So let's begin from the left hand side. In left hand side we have A raised to k plus 1, or we can split it into A raised to k into A raised to 1, right? Okay, let's put the value of A raised to k from the first equation, which is matrix A raised to k 0, 0, 0 b raised to k 0 and 0, 0 c raised to k. Now let's put A, which is given in the question, and here it is. Now to get our required result we just have to multiply two matrix. Actually both are diagonal matrix, right? So using the property of diagonal matrix we can get the multiplication easily. We just have to multiply respective diagonal terms to get the final answer. I mean to say A raised to k will multiply with A and it will give us A raised to k plus 1. Then B raised to k will multiply with B. So B raised to k, B raised to 1 will give us B raised to k plus 1. And finally C raised to k will multiply with C, which will give us C raised to k plus 1. Okay, rest of the terms will be 0. Okay, so tada, as you can see, this is the right hand side what we want. So we can proudly say that we satisfied all the condition of PMI. Therefore our P of n, which is A raised to n is equal to small a raised to n 0, 0, 0 b raised to n 0, 0, 0 c raised to n, is true. Ta-da!